All right, good morning. So we are going to get started with the first lesson of Geometry Chapter 1, so Lesson 1.1, and we're going to be talking about points, lines, and planes. We do have quite a bit of vocabulary to go through, so I wrote all of the terms on some index cards, which I will be holding up and then flipping over so you could see the vocabulary, and you're going to want to make sure you jot all this down in your notes so that you can refer to them. Right? The vocabulary in geometry is super important. Just like when you're learning a language, you need to know the vocabulary in order to understand sentences that are being formed in order to communicate in that language. And geometry is kind of a language in and of itself. So there's a lot of vocabulary that we need to go through. Okay. So the first is undefined terms. All right. Now, the definition for undefined terms, try to get my fingers out of there, which I'll read, and feel free to pause if you need to. Words that do not have formal definitions, but there is a general agreement about what they mean. Okay, there are three basic undefined terms in geometry, and they are point, line, and plane. So we don't have formal definitions, but when we talk about a point, we kind of have an intuitive idea of what a point is, what it looks like. An example of a point would maybe be like on a map. Points can represent locations. Okay, so point, line, and plane are your three basic undefined terms. All right, next we have point. Okay, so your definition for a point, even though I just went through and said it's an undefined term, we are going to try to put some words to it. A location in space that is represented by a dot and has no dimension. Okay, so an example, we use a dot to represent a point, and then we put a letter next to it. So this would be point A. If I wanted to talk, if this was in a diagram and I wanted to talk about it, I'd write the word point and then the letter A. Okay. The next is line. All right, so your definition of a line. A line has one dimension. It is represented by a line with two arrowheads, but it extends without end. Okay, and I drew an example. So here we have two arrowheads. All right, there's a cursive letter near one of the arrowheads, and then we have points A and B. There could be multiple points on it. There are infinitely many points. I'm just representing two of them. Okay, if I wanted to talk about this line, I could refer to it as line L. So if there is a cursive letter there, you can use that cursive letter to name the line, but you can't add your own cursive letter to a diagram. So a lot of times there is no cursive letter, but sometimes there is. Okay, I could also refer to this as line AB or line BA. With lines, you can flip the letters. It's still talking about the same line, right? If I'm talking about line AB, I'm talking about the line that goes through points A and B and extends in both directions forever. And it's the same if I flip the letters. Line BA is the line that goes through points B and A and extends in both directions forever. All right, the next term is plane. Okay, so a plane is a flat surface made up of points that have no dimension, or excuse me, that has two dimensions. Points have no dimensions, but a plane has two dimensions and extends without end and is represented by a shape that looks like a floor or a wall. Okay, so if we were in the classroom and I said, point out an example of a plane, many students usually point to the ceiling, to the walls, to the desktop. Those are examples of planes. Okay, so here is my example of a plane, and you can see there are three non-collinear points. I'm going to talk about non-collinear in a second. Non-collinear points. So I could refer to this as plane ABC. Okay, I don't put commas between those letters. I just put them right next to each other. You need at least three non-collinear points to determine a plane. You can have more. A lot of times, if there are points at all four corners, we would name the plane by naming all four letters and kind of just going around in one direction or another. Or if there is a cursive letter in one of the corners and there's no dot next to it, that is a letter just used to name the plane. So I could also call this plane M. All right, the next term, collinear points. And you just heard me say non-collinear. So collinear points are points that lie on the same line. Okay, so if you have 3 points that all lie on the same line, A, B, C are called collinear points. Okay, if there is another point, let me just, pretend that there's a point right here, and I named it point D. Okay, point D would not be collinear with points A, B, and C because it's not on the same line. Next, coplanar points, similar to collinear. All right, points that lie in the same plane. So points A, B, and C are collinear because they're all in the same plane. Again, if they were on the outside, like along the lines or on the 4 corners, they would still be coplanar. But if there's some random point outside the plane, anywhere over here, that would be a point not represented in the plane. So we would say it's non-coplanar. Right, defined terms. So we have undefined terms, the 3 basic undefined terms in geometry are point, line, and plane. And then defined terms, terms that can be described using known words such as point or line. So 2 examples are line segment and ray. Okay, I can define a line segment or a ray by using other terms such as point and line. All right, next we have a line segment or just a segment. Okay, a segment and a line segment are the same thing. All right, so a line segment consists of 2 endpoints and all points between them. All right, so I drew an example, segment AB and segment BA. They're the same segment. Okay, A and B are what we call the endpoints. So a segment goes from one point to another and all the points between. Even though I didn't draw actual little points, there are infinitely many points in between A and B. All right, so A and B are the endpoints, segment AB or segment BA, you can flip the letters around. Below I just drew another example. The yellow segment is segment CD. It has endpoints C and D. The orange segment is segment DE, or you can flip the letters around and call it ED. And then the green segment, you could call that segment CE, or flip the letters around and call it segment EC. Next, we have endpoints, which I just referred to in the last example. All right, so endpoints. Points that represent the ends of a line segment or array. All right, so I have a segment there. Point A and B are the endpoints of that segment. And then I have a ray, and A is what we call the end point of the ray. B is just a point on the ray, but A is the end point. Next, we have ray. Ooh, getting to the end. We have 3 more terms, including this one. All right, so a ray. Ray AB is a ray if it consists of the endpoint A and all points of line AB that lie on the same side of A as B. Kind of a confusing definition, but I'll explain it by the examples below. So here I have ray AB. A is what we call the end point. It's also we call it the end point, but I think of it as like where the ray starts. So the ray starts at point A, and it goes this direction through B and continues on forever and ever and ever. Okay, so I would call that ray A, B. We always name a ray by starting with its endpoint. So you cannot flip this around and call it ray BA. That would not be the same ray. Okay, in fact, it's not a ray because it doesn't go on through A forever. Now, this ray, I drew it the opposite direction just to illustrate how you still name it. It starts at the end point. It starts at point F, and it goes through E forever. So when I name it, I always start at the end point, and then I follow the arrow. So ray FE, okay, would represent this ray here. All right, and that is the only way to name that ray. If there were other points on the ray, we could name it differently, which I'll talk about in a later example. Okay. All right, opposite rays. So basically, very short definition, opposite rays are two rays that form a straight line. Okay, so the actual definition that I have on my index card says, if point C lies on line AB between A and B, then ray CA and ray CB are opposite rays. Okay, now again, my easy definition that I said, if you have opposite rays, the yellow is a ray, that's ray CA, and the orange is a ray, that is ray CB. If they have the same starting letter, the same end point, but go in opposite directions and form a straight line, they're what we call opposite rays. Okay, so ray CA and ray CB are opposite rays. And finally, the last term for today. That's a lot of vocabulary. We don't typically have this much. Intersection, the set of points two or more geometric figures have in common. Okay, so again, you can think about, in real life, the intersection of two roads, right? If you're on Main Street and Chester Avenue, you know where they intersect at that traffic light, right, at the top of Friends School. So two roads have an intersection. Well, two lines have an intersection. Here I have line M and line N, and what do they have in common? Where do they meet? Where do they cross? Point A. Two lines will always intersect at a point. Okay, and we'll talk about two planes intersecting in a minute. And I should say two different lines intersect at one point. Okay, all right. So we just have a few example problems to go through. I drew a diagram on the board here. You might want to pause and sketch the diagram and write down the questions that we're going to be answering so you can refer back to it in your notes. Okay, so we're going to give two different names to other names for line CD. Okay, so first you want to identify where line CD is. excuse me. So if you look at your diagram, CD, I'm talking about this line right here. And you might want to trace over it in a different color or highlight it on your paper if you want. So what is another way to name this line here? Well, a line, you can just flip the letters around, and that's another way of naming the line. Instead of calling it line CD, I could call it line DC. And make sure to put your line symbol above the two letters. And we don't put little dots on the line symbol when we're just naming the line. All right, the third way, or the second way that we're going to give to name the line, since there is that cursive letter near one of the arrows, that is there so that you can name the line. So you could also call it line M. Okay. Now it says, give another name for plane M. So if you notice in the corner down here, there's this letter, and note that there's no dot next to it. Like here I have point A, point C, point E, point B, because there's a dot next to it. But since this capital letter does not have a dot next to it, it's not a point, it's a letter just to name the plane. All right, so you can name the plane by picking any three non-collinear points within that plane. So look for points that are inside the plane and just pick at least three of them that aren't on the same line. So you could say something like ACE, okay? That's another name for the plane. Or ABE, okay? Or BCE, okay? As long as you pick three, at least 3 points that are all not on the same line, they can't be collinear, that is a way to name the plane. So we could call it plane A, E, B. Okay, or as another example, even though it only asks for one, you could also call it plane C, E, B as another example. Okay. All right, the next one says name 3 points that are collinear. So you look at the diagram and you want to find 3 points that are all on the same line. Well, this line, there's only 2 points that are on the line, D and C, but this line has 3 points, A, C, and B. So 3 collinear points would be collinear would be A, C, and B. Those would be your 3 collinear points. Then it says, then name a 4th point that is not collinear with those 3 points. So I'll write non-collinear. So you can still start with A, C, and B. Those are collinear. But as soon as you give me a 4th letter that's not on that line, then we say they're non-collinear. So A, C, and B are collinear. And then you could say point E, that's not on the same line. Or point D, that's not on the same line. Okay, so either one of those would be fine. I'll say E. As soon as you name a point that's not on the line, now those points are considered non-collinear. Next one says name a point that is not coplanar with points A, C, and E. So A, C, and E all are in plane M. B is also in plane M. They could have named that one if they wanted. Which point in this diagram is not in plane M? Well, it's this point outside, point D. Okay. Although, yes, point D is on a line that goes through the plane. Kind of imagine the plane as a piece of paper, and that line is a pencil that's like piercing through. Let's see if I can get a pencil. If I have one, I'll use a pen. Right, if this piece of paper is the plane, and the line is piercing through the paper and coming out the other end, that's what that's what you should be visualizing when you're looking at that diagram. So point D is not coplanar with A, C, and E. Okay. I just have 3 more examples, but let me erase the board. New diagram as well. All right. Okay, so for this diagram, a little crooked, but that's okay. All right, there we go. There's our diagram. Now the first question I'm going to ask is question number 5. What is another name for line PQ? All right, so what is another name for line PQ? So you come over here and you identify line PQ. Okay. So you could, again, just flip the letters and call it line QP. You could use the letter, I didn't draw cursive, but you could use that cursive, or non-cursive in this case, letter by the arrowhead and call it line J. You could also pick any 2 points that are on line PQ. So I could use point T, and I could call this line TP. I could call it line TQ. Any 2 points on the line can be used to name the line. So line PT, or you can flip it around and call it TP. Or you could use T and Q and call it line TQ, or flip them around and call it QT. Okay? So any combination, right, as long as you pick any 2 points on the line, those 2 letters can be used to name the line. So lots of different options there. All right, let's look at another question. What if I said, what's another way to name Ray RS? So number 6. What is another way to name ray RS. So let's go over and look for ray RS. So ray RS starts at R and goes through S forever and ever and ever and ever, right? So that's the ray we're looking at. That ray has to start with S, and then it can be, or you can use, I should say, you can use any point that it goes through to name that ray. So if I was to name it ray RT, well, let's trace over that ray and see if it's the same thing, right? So if I'm looking at ray RT, that means I'm starting at point R. That's my end point. That's where I start. And I go through T forever and ever and ever and ever and ever. Is it the same ray? It is. Okay, so ray RT and ray RS are the same. That is the only other way to name that ray. You can't flip letters in rays. That does not work. Okay, so that is the only option for that answer. All right, I just have one more question. Number 7. Name all rays with endpoint T. We'll start with that. And then my follow-up. Which rays are opposite rays? Okay, so it's a 2-part question. So name all rays with endpoint T. Okay, if it's the endpoint is T, that means you have to start at point T. So starting at T, you could go this way forever and name ray TR. So I'll write that one down. That's one ray. Start at T and go this way, so TP would be another ray. Oh, I drew a line instead of a ray, excuse me. It's my eraser. Drew the wrong symbol on top. TP. There we go. You could start at T and go through S forever, and then start at T and go through Q forever. So TS is a ray, and TQ is a ray. Okay, those are the 4 rays that have T as an endpoint, starting location. Now, which are opposite rays? Remember, opposite rays form a straight line. So TR, that ray, and TS, those are opposite rays because they form a straight line. TR and TS. And there's one other pair. Okay, what are the 2 others that form a straight line? Although I didn't draw a very nice straight line. Right, TP, this right here, and TQ form a straight line. So TP and TQ. Alright guys, that is it for lesson 1.1. I know it was a lot of vocabulary today. Again, we don't typically have that much vocab. Make sure you get your notes done, and I'll see you back here for the next lesson. Bye!